Hello everyone, welcome to CSE116, Task 3, Overview. Now, you guys are all probably so excited, you just finished your Task 2, you're feeling good, you got your linked list made, you fully understand, like, references, classes, objects, using linked list nodes, traversing them, using recursion, of course, because everybody did that. So, you all are so ready and excited for Task 3, but wait. I hear you guys. You might be saying that you're frustrated. You're a little exhausted from the amount of work from task 2. Well, in my humble opinion, task 3 is slightly easier, slightly shorter than task 2. And I think a lot of you guys are going to enjoy this. It's of course a very fun task, just like all of them have been. And we're going to learn some really cool stuff in this task. The game's going to be cool and even more fun, in my opinion. I think the end game in this is more fun than the other ones. So let's get into some stuff about this task. So, oh yeah, we're doing inheritance, and a lot of it. So this whole task is based around inheritance. You guys have learned about it in class. Have a little example here. So I have a base class called animatronic. And you guys might know the game Five Nights at Freddy's. All of these animatronics inherit from this base class, and that's because they share a lot of similar behavior. And if any of you have ever played those games, you'd know that, yeah, it's very similar. There's only a few things tweaked between them, but they're basically the same code. So that's what we're going to be doing today. We're going to be using inheritance to make some cool stuff, fix some stuff about our game, and we're going to refactor some code, which definitely needs it. And in order to use some of our cool inheritance features, we're going to use our refactoring to be able to load new games and stuff like that. And we're going to see, actually, right now, I'm going to show you guys what you're going to see by the end of this task and what the new games are going to look like. So here's my completed task 3, and let's just run the... Whoa, guys, I see you looking at my code. You really think I'm going to give you the answers for free? This is just our game, guys. This is my correct implementation, but I wouldn't give you that for free. Obviously, you guys want to make it yourself anyways. Like, we're here to learn and have fun. So, I'm going to play my game, and whoa, we got some new-looking things in here. And, yeah, so this is the pathfinding from task 1, or, sorry, 2. We knew about that, and, of course, all this is from task 1. But first thing we're going to see is, two new types of things. These are potions. If I run into this one, we're going to see, whoa, my health just went down. Now it's 2 out of 10. That's not good. So thankfully, though, we have another potion here, which is not going to lower my health. It's actually going to increase it. Now it's 6 out of 10. So that's fantastic, and the rest of this is the same, but there's actually some cooler stuff. And let me show you what that's going to be as well. All right, here we are. Yes, like, whoa, what is this? This looks different. Well, look at this. I could jump around and I can move. Because now, this is a different type of game. It is no longer a top-down game. It is a platformer. And this, in my opinion, is way more fun. Like, look, I could jump around, land on these things. If I fall, I die to a spike. So, I'm going to make it to the end here, get down to this part, and new level, and it's a death trap. And I infinitely fall and die. So, super fun game, of course, and you guys are going to see how to implement all that. Well, I'm not going to do it for you, but we're going to talk about it at least to get you guys off to like a better start, feeling more comfortable with inheritance, and yeah, let's go get into that. Okay, so first things first, y'all are going to want to read the handout, of course, of course, but I'm going to go through some of this. Like, this whole start section is very important to read, and you should read it because there is some confusion around that. However, I think it's actually just more productive if I show you a little example. It's hard for me to really show you anything in code for any of these specific implementations that you have to do. It might look like a lot, but a lot of this is just, honestly, pretty repetitive. And also a nice thing about this task is you only have to test this one thing. And there's no testing utilities. So this is a shorter task, and some of you may find it easier, but if not, again, we're just going to talk about it a little bit. A big, like I was talking about earlier, thing about this task is inheritance everywhere. And we're going to be making, like, objects that have different, maybe sprites and stuff like that. So if I were to like walk through you a little bit of potion, that would be too much. So what I'm actually going to do is I'm going to go through a process of maybe creating a different item. This is not in the game, so don't follow along. Just maybe watch and like see what I'm doing. But this item is not, like I said, you're not actually going to use this, but it'll go through the same process of like, okay, if I wanted to add something new, how would I do it? How would I use inheritance? And we'll show you that right now. So first of all, again, read this because I'm going to refer to this in a minute. But so in the specification here, the first thing that you say that you have to make is the potion, which I just showed you guys like in the previous thing what the potion is going to do. So there is going to be like a damaging potion, poison, or a healing potion, which is just a normal potion. And that's actually determined by what is passed in the potions constructor. If it's a positive amount of health, then it will set it to be a healing potion. If it's a negative, then it's actually a poison potion. And that will also change its sprite. So, changing its sprite, that might be, like, what does that even mean? So let's walk through this example here. So if I open up IntelliJ here, so this is start game, so it's nothing. But again, this is my completed task 2 here. Now, you're going to create your potion in common objects. You're going to make a new class called potion. Now, I'm not going to do that. I'm going to make a new object called food, and I'm going to show you how I decided this. So if we go into our game here, you're going to see this cute little picture. So these are some sprites, and you saw like some of these potions in the example I showed earlier. Now, these are what we're talking about when we say a sprite sheet. Now, if you would have read this up here, we're seeing that, like, some games, in 2D games have sprite sheets where we store a whole bunch of sprites together and we just pick and choose. So, for example, here we see the example where when we want to change something sprite, we set its sprite sheet file name to something and then the default location, the sprite location in that sprite sheet. So, if we actually want to find this, we could go to this actual image and find what row 3 column, or I think it's column 3 row 0, what this one is. That's referring to the doc because it's kind of fun to figure that out. So I am in data in your guys' game, so you could all go here, and then if you go to ground, and then I think it was Cliff, right? It was Cliff, yeah, and then column 3 row 0. So we do that, column 1 2 3 row 0. So oh, sorry, 1 2 3 row 0, whatever, it's one of these, right? Maybe it's 3 row 0, who knows. I actually don't care this much, but you can see that like we use these. And so if we look at the description of potion here, it says we should use user interface /icons /essential or whatever PNG, which if we go there, that's what I was just showing on user interface icons essential. So yeah, this is like the potion that we want, which is, it's cool looking, it's awesome. But again, I'm not going to make your potion. I'm going to show this little thing here, food. So you make it in common objects. So I'll right click here. I'm going to make a new class. I'm going to call it food, whatever. Don't follow along, of course. So if we're looking at the specifications of a potion, we are saying that a potion is a dynamic game object. Makes sense. We might have a lot of things that are dynamic game objects. A player, as we know, is a dynamic game object. You know that from all your testing and stuff. So let's say food extends. This is the keyword for inheritance. Dynamic game object. Great. Whoa, I got red. I did something wrong. No, you didn't. If you see this here and you're like panicking, don't worry. You probably know some of this from class, but even if we hover over it, IntelliJ will tell us there is no parameterless constructor, blah, 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 blah. So we got to create a constructor matching super. And if we just click on that, we will see it automatically makes us a food constructor, and we call the super method looking thing here, which is saying the super constructor, which you have to do in anything that inherits anything. So we will have to call the super constructor, and that takes parameters too, a location and a max HP. And if we went into dynamic game object, which I'm not going to do because my previous tasks could have some implementation in there, but its constructor takes in a location and that. Anyways, if we were to keep looking at this implementation, you could get confused when you say you should initialize sprite sheet file name to user interface because you're like, I don't have a variable of that name. Should I make it one? Should I, do any of that? No, you shouldn't. It exists because in our inheritance, dynamic game object has the variable called sprite sheet file name, which is a string. And if we were to just type honestly this dot, we are going to see a whole bunch of stuff here that is available to us. And you're like, wait, I don't see any of this in here. That's because it's in dynamic game object. I could go into it and show you guys all that, but again, I wouldn't want to show my implementation. So if you guys are curious what I'm talking about, if you go into your own dynamic game object, you will see stuff like default sprite location. So, and it might be a little bit higher up in the inheritance tree. I'm not sure, but you'd find it somewhere in there. So if we click on default sprite location, now we see we're getting that variable. So great, and we can set that equal to whatever string we want. And okay, something. Oh no, because this is a sprite location. What I wanted to get right now was the sprite sheet file name. And I wanted to set that equal to, since I'm making food, it's going to be the same spot here. So I'm just going to copy this exactly because I don't want to mess it up. You guys should do that. And I'm going to paste that in here. Great. So now we're saying we're going to use that sprite sheet. Now if I say this dot default sprite location equals a new sprite location, this is how you set it up. Again, this is explained up here, but I'm kind of just showing that off. And we wanted it to be food. So if we go to that sprite sheet, we will see that food is at column 1, row 3. Okay. Or column 0, row 3. Or is it 2? Anyways, we'll find out. Column 0, row 2. Okay. Well, we could actually figure out by comparing that to potion, which is at, yeah, great. So that's that, and I'm just making my food thing. I'm saying it's a different sprite. Now, potion has a requirement: override the collide with dynamic object method, and then it gives you some stuff to do. Which by this point, you guys should be able to understand the logic and implement that yourself. But I'm going to talk about that override thing. Like, if that's a little like overwhelming to you, let's just take a look at it. So if I were to go and say, yeah, no, it's not in this method. So it's a method, collide with dynamic game object. If I were to type collide with dynamic game object, even if I were to start typing it, you would see IntelliJ pops this stuff up for me. Oh, public void, like how does it know? Because it is a method that we could override from our parent or our superclass. So we click, I just hit enter there, and it automatically entered all this for me. Now you could see that, we have the override keyword, which is key. You could have typed this all without doing what I just did, where like it showed it yourself or itself, but you can do it however way you want. But this is almost great, exactly what we want. But so you could see that it provided us super.collide with dynamic object, which that's calling our supers collide. In some cases, we might want to use it, but if the doc doesn't say to use it, then don't use it. Some of your methods, you might see that it does say to, but I don't think in here it does. Also, I'm not making a potion right now. I'm making one I want. So I know that I don't need it. But I'm just going to say whenever you collide with this thing, I'm going to say, oh, you ate the food, and I'm just going to destroy this thing. This dot destroy is good practice. So just saying whenever you collide with me, destroy me. And that is all this thing is for food. I just want to show you guys a simple inheritance example. So this food class extends dynamic game object, meaning it is a child of dynamic game object. It inherits from dynamic game object. It has a location, a max HP. But yeah, so this is my food, and again, this is not potion, so don't think that you could just copy basically this and be fine for potion. There's a lot of stuff different in potion, like especially with the super class call here. So be careful when you're reading that doc. But yeah, this is inheritance. And lastly, I'm going to show you one more thing. An optional step is to see your potion, which you probably want to do, like you just made it. Why not? You could go into one of the levels from sample top-down game and add the new potion object. And I'll just show you I'll show you how to do that when you get there. Okay, so without showing my implementation for sample top-down game, I will show that if I were to get my static object, so we see this is level 0, whole bunch of stuff here. It's like, whoa, that's a lot. But you can see that we initialize a bunch of static objects, and then we initialize a bunch of dynamic objects. So currently our only dynamic objects that we add in level 0 are 2 enemies, which we know when you guys have played that level. I'm going to add another one. So what I'm going to do is just copy this line, and I'm going to add my new food. And I'm going to import that class, and I'm going to give it, so the parameters for it, it's a location and a max HP. I'm just going to give it some random value, 10, say. And I'm going to spawn it somewhere else. So the player, I think, is spawned at 2, 2. I'm going to spawn this at 2, maybe like 5. Yeah, sure. And then if I run my game here, yeah, so we're going to run our game, and we can see that we have our food. And if we collide with it, it just gets destroyed. Great. That's exactly what we made, and uses inheritance, and it's awesome. That's exactly the type of method you'll use to implement potion. Not exactly how you implement it, of course. You know, I keep saying that because I don't want you guys to like copy that and be like, why is it not working? Because it's right here. Follow this, read it. It's great. But moving on, we just have a whole bunch of inheritance stuff, and like, okay, I could like try to go through some of this, but like, again, I've tried to do this like a few times now, and I've read the stock, and I can't see how I could really help you much with this. It's pretty much similar to like all these examples I've shown. You know, you might like be creating a class and then adding some behavior to it. But some things I might go over are like this dynamic game object and physics engine with gravity. So like all these things are like, well, dynamic game object, you're preparing it for the platformer, so you're just adding like some simple state and behavior. That's not a big deal. You guys have done that pretty much this entire time, task 1 and 2. But then this, like, you know, this is a new class that you're going to make in this directory here, physics engine with gravity, and you're overriding the update object method, and you're adding the change in velocity. So yeah, remember that you are going to want to still use the superclass's update object method. Now remember how we could have called, you know, super collide with dynamic game objects in my food example? Well, it's kind of the same thing. We could call super dot update object, and it would pretty much do the same exact thing. If I were to go over here, go back into my food here, yeah, so we just see we have this dot destroy, but I could have gone super dot collide with dynamic game object, and then I could have, you know, done that as well. We didn't want to here, but there are instances where we would want to, which again is shown in physics engine with gravity. We're going to want to use update object and use it at some point, as we see right here. So make sure you read this through. Platformer wall, again, we're just making stuff and adding a little bit of behavior to it. It's not that bad. Once you do it once with potion, you could do it with pretty much everything else. The thing though to remember is how to do those sprites. If you get confused, again, look how I just did it. It made my food sprite, because you're gonna have to do that with like platformer wall and spike. So yep, that's stuff to think about. Oh yeah, another thing I wanted to point out is that like in platformer wall, we have some very specific conditions here. Like we talk about if the dynamic game object, so we're gonna be overriding the collide with dynamic object method inside platformer wall, since it's going to extend a wall, and we're going to call our super first. Like I said, we're going to want to do that sometimes, and then there's some specific cases here, such as if the dynamic game object is overlapping in the x dimension with the wall, set its y velocity to 0. Okay, now don't get too stuck on this, because I've already had people try to talk to me about this. Don't get too stuck on it. It is like the same exact way you see if something in the X is colliding in your detect collision. So it's very likely you might be able to look at your code for that and get inspired for how to make this. Depending on how you implemented it, though, it could be different. But again, try not to reinvent the wheel here. It's not too different from your detect collision, and it's just in the X dimension as well. It's easier. So don't overthink platform wall. Just when you see is overlapping in the X dimension, try to be strategic with implementing that. Spike is super simple. We saw how spikes worked in my example I showed you earlier. You just get destroyed if you touch one, and that's fine. Oh, and so we got like platformer level, which is very similar to our sample top-down game. Or no, I think it was just level before. But yeah, so you extend a level and you basically make a new level. Now, you guys are going to probably implement this whole thing and be like, I want to like test and play. Now, it is said that we're going to give you guys some levels on the course Piazza, but if you want to make your own, I will show a little bit of how to do that in a second here. Oh yeah, but one more thing before I do that. So like I said, like all of these aren't too bad. They look like a lot, and yes, it's just like a linear amount of work to do, but it's not like the previous thing isn't too different for the next thing. It's pretty just repetitive, and most of you guys might find this easier than task 2. So, but moving on down here, this is what I was talking about when I said you're going to refactor some code. So from task 2, we made that whole level system, like add level, get level list, set level, advanced level, premiere level by name. All of that functionality, you should move from sample top-down game to the base class game. You are literally going to cut your code out of sample top-down game and paste it into game. And what that will do will allow you to be able to extend more types of games than just sample top-down game from the base game class and still use your add level, set level functionality. It's really great. It's the power of inheritance. And yeah, we have to refactor stuff in bigger games all the time, in bigger projects in general in computer science. It just happens. So yeah, this is a common thing to do. We're going to refactor and move some code in there. If you're getting some issues, remember that you could always look back on your previous submissions in Autolab by clicking on View Submission button next to one of your previous submissions, and you could look at your code, because like if you accidentally delete something and you like are scared that you lost it forever, remember Autolab has it if you've ever submitted previously, which if you're watching this you have. So yeah, that's something to remember. Don't get too scared if you think you did this wrong. You could always fix it based on your previous submissions. And it's not too bad. Just read this very explicitly, and it's not too bad. We're just moving stuff for this stuff, honestly, which, that's a whole bullet point if you're just moving stuff almost. So, and, a little bit of extra functionality. But then we're going to make it a platformer game class, which is very similar to sample top-down game. And you could override init and add whatever levels you like. And so I'm going to show you guys a little bit how to do that right now. So after you guys have implemented everything and you feel like you're at a good spot, you can make your own levels. Right here I have a method called level 0, just like we did for sample top-down game. And yeah, so here's like my complete implementation. I have everything implemented here, and I'm just using it. So I am adding, so we know like a spike is a static object, platformer wall is a static object, and we are just going to be adding those and giving them a location. So you can see I do this a bunch of times with spikes, a bunch of times with walls, and then I add one goal. And then if I were to play this game, it's what I showed at the start. Now, if you can see my cursor here, these walls all around are preset. These are just there already. So whenever I'm adding a wall, I'm just adding like these here. And yeah, I could jump around, move, and do this. So yeah, this level here is my level 1. So just to show you guys, like if I wanted to add something else, if I wanted to make this level unbeatable, let's say I could copy this line where I add the goal, and let's say right under it, so this is the X and this is the Y. Let's say right under it, I want to add, instead of a new goal, I want to add a new spike. And then I gave it 10, 2 instead. So I put it right under the goal. Now if I play this game, yeah, now this level is unbeatable unless you could like somehow cheese your way up there. But yeah, so now you can't really beat this level. And that's just how you do it. I can't get up there. But yeah, so that's just how you make a new level. And then you want to add this level and you're in it, just like you would in sample top-down game. I'm not going to scroll up because it's just some little implementation, but still, you guys should be able to do that on your own after that. And if you wanted to use my level, like you could copy this like and play it. Yeah, so that's pretty much the task, guys. And then the testing requirements are just testing platformer wall, that's the thing with like, okay, if I'm overlapping on the X, set my Y velocity to 0, make me grounded. It's your only testing requirement. This task should not be too bad. It is a little tedious. If you don't understand inheritance, it could be a little daunting. Remember to read this whole handout here, and good luck, guys. And don't worry, we're going to get way more into depth about way more complicated things in Task 4, so if you guys were worried that things were getting too easier, don't worry about it. And yeah, good luck on your Task 3. I'm sure all of you will pass on your first submission, so good luck.